So if you have been following my blog, I started my lawnmower project almost 3 years ago, and then I didn't like the response time, and eventually I gave it up. I was not working on it for until this December, and that's when AI came along, and I decided to pick it up again and see what I could do. So before I go there, talking about AI, two things. One is AI assisted development, where you build everything with AI, but you don't actually let AI do the operations. And the second is when AI is actually involved in your operation. So right now what I have done is really AI assisted development. I have used AI to build models, to generate connections, and if you saw my previous blog, I was able to accomplish in about 1.5 day what took me 6 months in past. So the gain is there, but again it's very, you have to be careful about how you use it. So I'm going to today just explain how this thing is set up. Let me zoom in a little. And I have actually split my screen in two. So this is my laptop opening the browser from the NVIDIA, and this is actually the NVIDIA screen. So if I need to restart something, if I need to run a script, if I need to install device drivers, I can do that here. But if I just need to see what's going on, I can see it on this web page. And then I have an Android app, again built by AI, which actually it has grown significantly in last few days because I had to add a lot of calibration and testing. So what I ended up doing was this. So the flow is, you set this up with a, actually I should explain this too. This is nothing but a USB based RF transmitter, and the same transmitter or transmitter and receiver, and the exact same transceiver is set up on my NVIDIA. So when I start this, as you can see it's red, meaning that's not detecting this. So what I'm going to do here is rescan the ports. So because it was not on, the NVIDIA didn't know what to look for. Now it is looking for it, and if you can see now it has turned orange, which means now they are communicating. So at this point you can see the heartbeat is going between the phone and this has a range of about 1.5 kilometers. So I can be in my yard anywhere and I'll be able to control the lawnmower. That's the idea. Now if I do a start and then if I run this, you can see this works as a joystick, and there you can see the voltage levels going up and down, right? The other thing we can do is I can set it in the, where is my modes? Gyro mode. Now with one hand what I can do is I can increase the speed, so you can see there, and then I can just use this tilt to control it. It's expo, so you see that you have to go all the way down to be able to control it. Anyway, stop. But what I wanted to do was explain how everything is connected together. So let's do this. Let me zoom into, alright. So what I have here, oh, I didn't connect my Arduino. Well, that's only for monitoring. So this is an NVIDIA Jetson Nano, which which has onboard AI capability, and which is what I will use next to train my model and use it in real time. This is a GPS chip. There is a switch to cut off so I can use it with hands. And these are 8 relays. It's a relay bank that controls the safety switches and it bypasses the system. So I had to design a switching system to make sure that when I wanted to use it by hand, there was a way to actually do that. Oops. Let's go back here. It's better. So okay. So the flow here is the Android app on this phone connected with this RF works as a, they call it a dead man switch. So if for some reason I think that the mower is losing control, it has lost connection, or it is going into a neighbor's yard or hitting someone, if I just disconnect this, that thing stops. So it's a heartbeat. Within a second, if it doesn't receive this, that stops. And also start. So it started. And then I can literally control all 8 relays if I need to turn off the seat switch or the neutral switch, or I need to bypass the controls. So literally all the switches are off at this point. So I can control all those things from my test panel, and then I can turn off all on and off. But that way I have a complete control over the lawnmower while it is in the field. Now what I'm trying to say is to build all of this and do the changes if something didn't work right. It is very, very rapid when you do it with AI, and that's the gain here. Okay, it's still in gyro mode. I'm going to turn this off. So that's basically, did I explain everything here? Let me remove this power. So NVIDIA shut down. Remove this. Okay. So if you look at this NVIDIA chip comes with 4 USB ports, and I have my RF transmitter similar to what I have before, but I am also connecting, I don't have them right now, but I'm also connecting 2 USB cameras to visually isolate the grass as it is cutting. I told you these are the relays, GPS module. This is a DAC, digital to analog converter. Because NVIDIA doesn't have a DAC on board, I had to install a different DAC on top, and I had to cut holes in the cover because I couldn't get all the cables out. So most of these cables are going to the relay. This connector is going to this DAC, and then DAC is outputting to the relay, and then relay is going to these plugs, which when I take this system to my mower, I can just connect that. Now in the mower, what I have done is I have spliced, or actually taken out both the original connections and the system and the switch. So if I want, I can connect them together and then I can ride like nothing happened, or I can just connect these to this system and then this one starts controlling it. So it's I like the way it is. The biggest problem I'm running into is calibration. So the voltage expected by the mower is off because there is one Hall effect sensor that is connected this way, so high and low, but they have taken the same connector and connected on the other side because they could not find 2 different types of sensors. So this sensor is going positive negative, this sensor is going negative positive. So I had to invert voltage on one of the sides, which is why when I was doing this, one of the things was going backwards on the phone. So I'm still getting there. That's why I had to create this whole calibration panel. So I still am not done with that. I need to take it to the mower, do some simulations, record what the voltages are, and then ask NVIDIA to actually provide those voltages so we can actually control the mower. So that's when this part of it will be complete. The next part would be actually using AI. So with the camera that I'm planning to mount, I'm going to take pictures as I mow. I'm going to train a model with those pictures to come up with an intelligent way of identifying which part is more and which part is not, because as the mower is moving you need visual indication to see if you have drifted off. So that's going to be very computational heavy. I'll do the fit and the training. The inference itself is going to be very CPU intensive. So we'll see if this little nano can handle it. If not, we may have to upgrade to a more expensive model. So yeah, that's where we are. Hopefully, will I'll be able to do it in next few weeks. Like I said, AI makes it really fast. So this is pretty much ready. I just need to calibrate the voltages a little bit and then I'll do a field test. But I wanted to show how it is done here, so at least the system is clear, right? Thank you for watching.